Hi, my name is James Lynn Judy, and for this video, I'm going to be going over part C of our experiment. The first thing we needed to do in our experiment was choose a letter A through E, and the letter that I chose was A. And the first thing we had to do was describe it, and it looked round, smooth, it was silver, it looked like kind of like pebble ball, and it was like, yeah, just shiny and round. Then we had to tar our wading boat. And in this example, I'm going to use this book as my scale. And I will be placing, let's say this is, the boats. And right now, the weighting scale says, I don't know if you can see it, 1.87 grams. Tarring the scale would make this zero out, and it would make the weight 0. So now we could actually measure our substance with the boat, because we're not allowed to put the substance directly on the scale. So tarring the weight boat allows us to zero out the weight and actually calculate the weight of the substance accurately. And I would also like to hint out that I think it would be also best to wash and dry the wading boat, because any residue also has mass. So that's one thing to mention. The next step in this project was to find our volume of our irregular object through water displacement. And my substance was A. So we had to... The initial volume was 10 millimeters. And also, it is important that you fully submerge your item under the water, because it will give you an accurate reading if you don't fully submerge the item in the water. Because if you put part of it in, it will only give you the volume of part of the object kind of thing. And also, make sure that there isn't any air bubbles in your water, because that also can give inaccurate readings. And this is my little diagram for my volume through water replacement. This is so bad. I don't know if you can see it, but this is the initial volume of the water. It is 10 millimeters. And after fully submerging my item, the millimeter went up to 16. And with water, with the replacement method, you would subtract 16 from 10, and that would give you a volume of 6 millimeters. The next step in our process from our found volume is to find the density. And the way we do that is we divide mass by the volume. And my mass for A was shown to be 50.10. So 50.10... forgot to show you. 50.10 divided by 6 is equal to 8. And the next thing we had to do from this was find the average density, and I use the same density for all 3 trials. So it was 8 plus 8 plus 8 divided by 3 to get an average density of 8. And based on my average density, I found it to be nickel. Because before significant figures, I had 8.35, which was close to 8.9, I think, that the nickel was close to. But after significant, it went down to 8. But I still think that my data was very similar to nickel. And I had... the difference I might have experienced from the readings was probably the temperature and stuff. And I also saw in the picture for A that one ball was kind of near the meniscus, kind of breaking it down. And also, wash and dry your beaker before using them, because residue is added mass.